We shall now look at some results on sigma notation. The first result tells you if you consider this summation with two terms, alpha UR plus beta VR, alpha and beta are constants, and the result tells you you can split it into summation with alpha and beta written outside. So we just need to consider alpha times summation UR R from M to N plus beta summation VR R from M to N. So one example is if you consider 3t squared minus 4 square root t. Since 3 is a constant, you can write it outside. 4 is a constant, you can write it outside. So you consider the two summations on the right hand side to find the answer. So I'll explain to you why this is so. If you consider summation R from 5 to 11, 3 UR plus 4 VR. If you write it out, right, you'll sub R as 5, which gives you 3U5 plus 4V5. And then you sub R as 6, it gives you 3U6 plus 4V6. And then you sub R as 7, 8, 9, 10, 11. So it gives you, the last one will give you 3U11 plus 4V11. After that, right, you can group all the U terms together. You can group 3U5, 3U6 until 3U11 together. So it's 3U5 plus 3U6 all the way until 3U11, and then you plus the V term, 4V5 plus 4V6 until 4V11. And then we know that 3 is a common factor to the U item. So you can write it as 3U5 plus U6 until U11. Then 4 is a common factor to V5, V6 until V11. So you can take out 4 as a common factor. And it's V5 plus V6 until V11. So after that, you can rewrite it in sigma notation. So it's summation R from 5 to 11 UR plus 4 summation R from 5 to 11 ER. So that's the reason why constant can be written outside. So 3 and 4 are constant, can be written outside, and you can split it into two summations. Next, we'll be looking at the second result here, which tells you if you sum C, if you consider summation C R from N to N, then the answer is just C times N minus N plus 1. C is a constant. I will show you another result before I show you this result. Okay. Summation, if you consider summation R from 1 to N, 1, this answer is just N. So I explain to you why. And then you can also have this result, summation R from 1 to, so R from M to N is actually N minus N plus 1. Okay. Here is 1. If you consider summation 1, R from N to N, then the answer is just N minus N plus 1. Okay, so I'm going to show you why summation r from 1 to n, 1 is n. If I ask you to find summation r from 1 to n, ur, you'll be finding u1 plus u2 all the way until un. So now let's say I tells you u r is 1, meaning I tell you u1, u2 all the way until un all are 1. So since ur is 1, then left hand side is just summation r from 1 to n 1. And on the right hand side, u1 is 1, right? u2 is 1, u3 is 1, all the way until un is 1. So we'll be adding 1 n times. So the answer is n. So that's how we get this answer, this result. So that's how we get this result. Summation r from 1 to n 1 should give you n. Basically, this summation tells you are finding 1 plus 1 plus 1 plus 1 n times. Next, I want to show you summation r from m to n 1 is n minus n plus 1. Okay. First, let's look at summation r from 1 to n ur. This would be u1 plus u2 all the way until un minus 1, then un plus 1 all the way to un. If you add u1, u2 until un, before you reach un, you should reach un. You are assuming m is less than n. Okay. So you see that if you look at summation r from m to n ur, right? Then you can write it as summation r from 1 to n ur. But this is too much because all these terms are extra. All these are extra. What you want is what you want to sum from un plus 1, un plus 2 until un. What you want is from this term onwards, from un onwards. So you should subtract away summation r from 1 to n minus 1 ur. So it means to sum from un onwards, to add un plus 1, un plus 2 until un. Then you can sum from u1, u2 until un. Then subtract the sum from u1, u2 to un minus 1. And now you just take ur to be 1, like what we did just now. Then you will find that if you sum r from n to n 1, then this answer is just n. And this answer should be n minus 1. This answer should be just n minus 1 because u1 is 1, u2 is 1 until un minus 1 is 1. So you're adding 1 n minus 1 times, right? So this will give you n minus n plus 1. So that's how you get this result. And after that, right, to show this result, you just consider this. If you consider summation r from m to n, right, c, then you just take it as is summation c times 1, then r from m to n. Then c is a constant. The first result tells you constant can be written outside. Remember just now here 4 constant can be written outside. So we can rewrite this as c summation r from m to n, then 1. So we just write the constant outside, c outside. Okay. So with that, right, the answer should be just c times summation 1 r from m to n, which is n minus n plus 1. So this should be c bracket n minus n plus 1. So that's how you get this answer, this result. Summation c r from n to n is c times n minus n plus 1.